And so it is. All right, welcome to Closures. So to start with, I'm gonna have you guys do some reading because I have talked about closures before, believe it or not. So I'd like everybody to take a sec and read that article. All right, let's talk. So there's another metaphor for you. Got this binder. I got, let's see. I got my wife's laptop case. Put the binder inside the laptop case. Okay, so this is a function that I can open up and take another function out of. I take this piece of paper and put it inside of the red folder. I'm really putting it inside the blue case. I'm also putting it inside of the red folder because the red folder is in the blue case. So I put it into the blue case, it also goes into the red folder. And when I call this function, I get this thing back. Then I can call that function and get this thing back. That's a closure. More simply, you do shit like this all the time. We just don't use that word all the time. So like this thing where we're using user here, but user was defined in this other scope, that's a closure. User, this scope in here closed over that variable in the outer scope. Cool. Ask me some questions about closures.
Well, if no one has any specific questions, could we maybe just make one
Sure.
similar to the one in the article?
Sure. All right, so I'm going to make a Dribble script file. Nothing up this sleeve, nothing up this sleeve. So if I have some students and got Hannah and Toby and Alice. Cool. So closure can be as simple as this. That's a closure. I didn't pass students in. I accessed students via closure. Where you see this more often is if I wrap all of that in a function. Like this. So now what I can do is call main, and that'll get me that students function. That's that. And if I call the students function, I get back the list of students. But here's the wild thing. Is when I called that function, that's where like students existed. And I get this. That main, that doesn't exist anymore. But still, this get students function remembers that it used to have access to this thing called students. And so it like hangs on to it. So that'll end up working.
What do you mean when you say the function main no longer exists?
So when we call a function, it goes top to bottom. So right here, when I'm calling main, it goes, all right, I'm going to declare a variable called students. I'm going to set it to this array. First thing in the array is this. Second thing in the array is this. Third thing in the array is this. Now, I'm going to return out of this function this other function, and its body is whatever. That function, the main function, has been completed at that point. And like everything other than the return value, that's gone. Another way you could think of that. Okay, so I call this function count as 0, then it's 1, then it's 2, then it's 3, and then I return it. But when I call side effect again, it doesn't remember that the count was 3. It starts all over again. The only purpose of a function really is like to get to this return value. Closure is a way that we can remember shit from a function body.
So what is student's function again? Oh, never mind. You're defining it on the line above it and then calling it below, right?
Correct. So the return value of main is a function definition. So in this case, that. And so then I call it, it's just like I'm calling that function.
And so why wouldn't you just use main? Why do you need to turn it into student's function?
Because student's function is this function definition. It's not the function's return value. I didn't invoke the function. I just got a function definition back. If you want to see something really fucking crazy, check this out. I can do main and invoke it. That's going to evaluate to its return value, which is that function definition. Function definitions, why I can invoke those. What?
So it's basically just making it so you don't have to invoke something in a nested way.
Yeah, well, yeah. So this would be like that nested invoking. It's called currying, if you're curious. But yeah, I'm just doing that in 2 steps. This and this are the same thing. More questions about closures?
So I was having this issue where I was like setting a constant equal to like a function, and I invoked the function, and like it was automatically like running the function. Is that what you mean when you say like it evaluates the function definition?
So this right here, when you invoke a function, you get its return value. Its return value is this function definition. It doesn't call it. It just gives it back to you. There's no equivalent concept in Ruby, by the way. I think that's a frequent like brain mismatch. But functions are just values. They're like Booleans, they're like strings, arrays, objects, anything else. A function definition is also one of those things. So we can store it in a variable, we can pass it as an argument, we can return it from a function as well.
So what specifically about this can't be done in Ruby?
Having a standalone function that gets returned. There's no standalone functions in Ruby. There's only methods of objects.
This has a lot to do with referential transparency, right? Where a function is that value.
Yes! So since this invocation right there, that's like I just typed out that function myself. So like, this, oops. this and this are the exact same thing because of referential transparency. Invoking a function is equivalent to whatever its return value is.
Wait, but why aren't you passing in the constant of students so that the function get students can access that?
Well, like this wouldn't work because it can't see students there. And this is part of what's cool about closures, is that this thing over here, that gets like bundled up with this function. So even when that function is completely standalone, like it is here, it still remembers the environment that you declared it in. That's what would be different about that and that. This student's function here, the first one, oops. Stop. The first one isn't going to error out because it remembers students. I was born in an environment with students in it. This one, that's going to throw an error if I try to call it because it goes, what the fuck is students? Well, it's not going to throw an error. It's going to return undefined, but this one uses the magic of closure, is it has closed over its environment. Ask me more questions.
So is closure kind of like the side effect of scope?
Yes. So like JavaScript scoping rules allow you to use closures. Not every language does, most do, but the way that like JavaScript's little Russian nesting doll scope thing, when you're referencing something that's outside of your particular Russian nesting doll, you're accessing it through closure.
Does closure only work for like the function that's within that next function up? Like it only has access to what's in like the next level up, or does it have access to like if it's like, okay.
So I could have a function outer that returns a function that returns a function. And I can put students all the way out here. And that still works. I could do outer, and then I'd get my list of students.
Okay, so I have another question. Why, when you call outer, does it not just like automatically filter through the other functions because the other functions are what are being returned? Like, why do you need to have this like 3 bracket after outer?
Because the thing that, great question. The thing that comes back from outer is the function definition of main, not the function result. It doesn't call it. It just gives you that function definition back. Same thing with main. When I call main, I get the definition of get students back, but it doesn't invoke it. That's why I have to actually invoke these things, because all I got back from them was their definition.
What did you call that on line 23?
That is currying.
Curry.
After Haskell Curry, a 20th century mathematician. And what's wild about currying is that we can like pass stuff in there. We can say some number and some string, or call it some other number. And then all the way down here, I can return some number times some other number. Let's simplify this a little bit. Okay, so let's say I did this. I can do that. For this inner function, some other number was its argument. Some number it got through closure. For those of you who've scratched at functional programming a little bit, the power of doing something like this is I don't have to query these. I can do what's called partial application and get something like now I have a function that will multiply something by 3. So I can do something like that. I can build complex functions out of smaller functions. That's like the core idea of functional programming.
So what does times 3 equals outer 3 result in?
This function definition.
Oh, okay, it's just the definition.
Just the definition, which is why I can invoke it down here. But like, it remembers that I'm multiplying this by 3 because it's accessing that through closure. This thing here turns into 3. And when I get this inner function definition back, it remembers that that variable used to be in its scope. The really wild thing, and like you'll see this one of these days, and so I'm showing you this, not because I think you should start using it, but I don't want you to throw up the first time you see it. We can rewrite this using fat arrows like this. This and this are the same thing. That is the return value of this function that takes in some number as an argument. The entire thing is the, let me do that, all right. The entire thing is the return value of this function that takes in some number. Your head hurt yet? This is probably the most academic thing that we cover in the program.
Yeah, my head hurts.
Good. One of these days you'll wake up and get closure and you'll never lose it. It really, it's not a complicated concept. It's just a very unnatural one. And regardless, I would try to have a solid definition of a closure at the ready, because somebody's going to ask you this in an interview someday. It's a super common interview question. What's a closure? Well, it's when an inner scope references an outer scope.
What was that?
It's when an inner scope references an outer scope. That's a closure.
Could it also be when an outer, sorry.
I was just
Could
gonna
it
say,
also be like when
go
an
ahead.
outer scope, hold on. Sorry, I don't know what's happening.
Go for it.
Is it my end or your end? I don't know. Okay. So would it also be like when an outer scope returns a function definition of another function?
Not
Function
necessarily.
definition.
So if I just have, that, that's not a closure. There needs to be something in this outer scope that the inner scope is hanging on to. That's a closure. That's just a higher order function.
I think I may have unwittingly used this
You
before.
probably have. There's like, you have to use it to solve a lot of different problems, especially in JavaScript. Anything else?
Is using like a class constructor considered closure, or is that like some other object-oriented idea?
Yeah, that's not closure. That's an OO thing.
Okay.
Closure is a functional idea. Like it usually is not really a thing in OOP. Anything else? You're beautiful. All right, we're gonna do some React stuff next. I'm gonna do that in a